Hello, good evening, everyone. Today we are having like solve with us session for week 2.
Good evening, ma'am.
Good evening. So you guys have to join peer deck. I'm sharing the password. It's here. Uh, are you able to have the password there? Start joining the peer deck. You have to put the password there, and then you will be able to join. Like
Ma'am, in this way, uh, there is no space.
no space here. I'm waiting for 5 minutes. Just you guys just join it, so you can answer simultaneously when we will start the session. It will be a like question answer type session where you will see this question on the screen, and there will be a space in your mobile or laptop where you have to put your answer. See, it's not graded, but for practice, it's good. Like you will, it will be a interactive session if you do along with that.
Can I ask a question while others are joining?
Yeah.
In the chat, I have sent a image.
Okay.
If you don't want to check the image out, I can just ask you this thing. So there is a pie chart that is given, and the pie chart, each slices has the percentage of the weightage. Okay.
Okay.
And the question asks, what is the aggregate distribution?
Okay.
So I'm confused whether it needs the exact frequency or the percentage or the ratio.
Fine. Aggregate distribution, like you have to uh, add it, like whatever, like whenever aggregate distribution is there, it will be with more than one category. Then
Right.
you will have a aggregate distribution. So here it is physics, maths, and biology. So you have to calculate for that.
No, I get that. I'm asking whether
Okay.
I should calculate the number of physics.
Frequency. Yeah.
The exact frequency is being asked, right?
Yeah.
But
For physics, math, and biology, combining all.
got it. Yeah, I will combine, but I was wondering if I enter the just the percentage, if I just add up all the percentage, it's still kind of an aggregate distribution, even if it's in a percentage form.
If it is in percentage form, then it's a like kind of share or contribution,
Right.
not the aggregate distribution
Okay.
or aggregate frequency.
So basically, whenever I see this distribution being asked, I should assume that they're asking me for the exact frequency, right?
Yeah.
Okay, thank you.
Oh. Okay. Some more students are yet to join. See, the password will be there in your screen during the whole session. It will be on top right corner. You can uh, see the password and put there. So we'll start now. Fine. So please keep ready your pen and paper. It will be a like you have to solve some questions where you need some calculation. So if pen and paper is ready, so it will be easy for you. Fine. If you need more time for any question, then just let me know. So I will increase the duration for the time. And don't answer on after unmuting yourself. You have to answer in your mobile or laptop where you will have this kind of space. You have to put your answer like that. Okay, so let's start. So in week 2 we have learned some frequency distribution, right? there was one thing was frequency distribution, and another term we learnt was relative frequency, right? Where we learnt whenever there is any category and you are just calculating the number of particular quantity, like quantity of particular category. At that time, it's nothing but the frequency of that particular category, right? And sometimes you so that was the frequency distribution. Let's say you have a particular data set where there are some 5 different categories. That means 5 different kind of distinct values or categories. Like data is for that 5 particular distinct values. Then I would say it as a category, like because you might be familiar with this word category now. So that's why I'm using category. And then you have to calculate the occurrence of particular category. And that's what the total number for particular category is its frequency. Fine. And when you form a table for all these 5 categories and their counts, that is nothing but the frequency distribution. Then there is a relative frequency term is there. What is relative frequency? So it's nothing but the actual frequency of that observation or category divided by the total number of observations. So it will give you a kind of portion or a percentage proportion of that particular item or category. Fine. Let's say there are some A, B, and C, some 3 categories are there, and you got to know that, okay, for A, there are some, let's say, 80 occurrences were there. For B, it was 10, and for C also it was 10. Then this is what your frequency distribution. When you add one more column where you have relative, you are calculating relative frequency at that time. Yeah, anyone want to answer what should be the relative frequency at that time? It will be 80 divided by total number. How many observations are there? 100, right? So 80 by 100, which is nothing but 0.8. And for B, it will be 0.1, and C, it will be 0.1 again. Fine. This kind of things are there, which is known as relative frequency. So when in general we want to talk about any categories or observations, then we choose to have relative frequency, as it will give you a particular proportion for particular category. Fine. So we will do some questions, so it will be more clearer. Is there any doubt regarding these 2 kinds of distribution? Then
No,
please.
ma'am.
Okay.
No, ma'am. No, ma'am.
So let's have a question there. See, there is one question. It says, consider the following frequency table to see how many students in a class have got marks between given intervals in statistics. So here in table, they have given the marks range, and table is not complete. So obviously our task will be to complete the table. So this is what the range of marks. The student who got the marks between 50 to 55. Frequency is not given. Relative frequency is also not given. And for rest of some of the things, frequency, relative frequency, both are given. So the first question is, find the total number of students in the class. So I will just give you some time. You just try it. Then we will discuss the solution for the question. Fine. See, you have frequency of some of the categories and relative frequency for one category. Just check how you will use your formulas and things to find out the total number of students.
Hundred students.
Please don't don't unmute and answer in the live session. You have to join the peer deck and answer there. We'll check there. Once everyone is done with that, we will have discussion over it. Fine. Password for the peer deck is given on the top right corner of the screen. You can join like that. So yeah, how to proceed with this question? Now now you can unmute and speak. See, we want to calculate the total number of students. Fine. Hello.
I have.
Yes, ma'am.
Yes, ma'am.
So how will we proceed? We want to calculate total number of students. That means the sum of these frequencies. Fine. So
Yes, ma'am.
here we have given with the relative frequency. Fine. So just take what is the formula for relative frequency. So what's that? This is nothing but
Frequency by
the
total number of observations.
yeah frequency by total number of
Total number
observations.
of observations.
Yeah, I just write total, right? Total number of observations. So for this particular category, when students are getting marks lying between 55 to 60, that means this one is one particular category, right? For this, we have relative frequency,
Yes,
we
ma'am.
have frequency, so we can find out. So what is that? This is nothing but is 0.2,
0.2
and this is 10 by, let's say, x.
total.
Yeah. So the calculation is x is equal to 50, right?
Yes,
Isn't it?
ma'am.
So the total number of students are 50 here.
Yes, ma'am.
Okay,
Right.
fine. So let's move to next question. Here is the description for the same, like what we have just discussed. Then the next question. The rest of the data is same, and the question is different. What is that? It is notice that the number of students for marks in the interval 60 to 65 is one less than the number of student in 50 to 55. Okay. They have given some hints for the frequency of these two categories. Then find the total number of student who got marks between 50 to 55. Okay. If you guys need more time, then just let me know. But please join the peer deck and put your answer there. So here, it is given that number of students who scored between 60 to 65 is one less than the number of students who scored in the interval 50 to 55. So we will just assign, let's say, number of student who scored 50 to 55, let's say they are X, and for 60 to 65, it's less than 1, then comparatively to this is. So I will say it X minus 1. Then we know that the sum of all the observation is 50 as we have calculated in our previous example. So just sum it and find the value of X, right? Sum all these 4 quantity and equate it to 50 and you will get the value for X, right? So what you got the value for X?
15.
15.
Fine. Yeah. So it is nothing but 15. The solution is here. Fine. So next one is very it will be very easy. See, it is noticed that the number of student who scored marks between 60 to 65 is one less than the number of student in the who scored 50 to 55. Find the number of students who got marks in between 60 to 65. So I am just allowing some 30 seconds only for this particular question. Okay. So what did you get? 14, right?
14.
Ma'am.
We
14.
just subtract one number only. Okay. So another one. What it says, calculate the relative frequency of the marks in the interval 60 to 65. So this also you can do, right? Because we have now frequency distribution, so relative frequency will not be a big deal now. Yeah. Done?
Fine to 8.
Yes,
Yes,
ma'am.
ma'am.
Yeah. So this is nothing but the 14 divided by 50, fine. That's what
Yes.
you have to just put the values inside it. That's it. It's a 0.28. Then, yeah, this one is some different question. See, here you have given with the two data set, and you have to find the relative frequency for categories listed in the data set 1 and 2. So you have to find for both of them and write your answer as a separated by comma, because you have to put some 6 entries, right? So just start. It's just looking like a very calculative task, but once you add up all, you will find something that this is not that much calculative one. But there will be some question in where you have to calculate. Someone is putting the answer in chat. Don't do like that. You can join the peer deck, no? Okay. So here, when you add all the data or observation in data set 1, you will find it's 10, and here it's in data set 2, it's 100. So the calculation becomes easy once at 10 or 100, and you will find that the relative frequency for both of them is equal, as here relative frequency will be 4 by 10, that's nothing but 0.4, 0.1 and 0.5. Fine. Similarly, here it will be 40 by 100, so that is nothing but again 0.4. For B, it will be 0.1, and for C, it will be 0.5. Fine. Do anyone have any question here or doubt? Anything?
No.
No, ma'am. Go ahead.
Okay,
No, ma'am.
fine.
No.
So yeah, here is the solution, and yeah. So another one. Here again, two data sets are there, and some data is there. Categories and frequency distribution is given, and they are asking, will the relative frequencies be the same for data set 1 and 2? So just check whether they are same or not. Okay. So here again, you will find some similarities here. It's the sum for the data set 1 is 10, and sum for the data set 2 is 20. And you will observe that every observation is almost double. So yeah, the relative frequency will be same, right? Was it?
Yes, ma'am.
Yes, ma'am.
Yeah. Fine. See, there is some theoretical question. It says choose the correct statement from the following. Two data sets having the same frequency distribution will always have the same relative frequency. Second one says two data sets having the same frequency distribution cannot have the same relative frequency. Third option is two data sets having the same relative frequency will always have the same frequency distribution. So I'm just, I think 1 minute will be more than enough. Okay. So, what should be the correct option here?
Option 1.
Ma'am, option 1.
Fine. Why not option 3?
Ma'am, because
Option one is
we
correct.
can have the same relative frequency, but it can be the frequency distribution can be different. Like if we have total number of observations 100 and in one we have 10, but in the frequency distribution where we have 10, we have 2, we get the relative frequency 0.2. But at that 100, if we take the relative frequency 0.2, it is 20.
Yeah, fine. Last two examples
In the
were related to this only,
previous
right?
question, we
Yeah.
have solved it.
Yeah, the similar that two previous questions are have the giving support to that statement that statement number 3 is false. So yeah, option 1 and 2 were just opposite to each other. So we have seen that if the frequency distribution is same, then obviously their relative frequency will be same. Because because the number of count for the particular category and total number of observation will be same, so relative frequency will be same. Fine. Then there is another thing we have learned, that was bar chart. So in bar chart, what do we do? What do we used to do? If there is a frequency distribution for any categorical data, then we used to present it in a bar form. We used to plot the category versus count or frequency, right? And it was very simple. If here I'm saying, okay, A, B, and C, these are some categories for particular data set, and there is some frequencies given for them, then we will have a graph like that. This kind of chart is bar chart. And we also seen the when to use bar chart, pie chart, Pareto chart, right? Similar, today we will be having examples based on that, and you guys will decide which type of chart we have to use when the questions are of different context. Fine. So let's see. There is again a Pareto chart was also there. The main difference between bar chart and Pareto chart is that in Pareto chart, the order is maintained. Like when bar chart is there, the ordering of categories or bins doesn't matter. But when it comes to Pareto chart, these beans or categories should be arranged in either descending or ascending order of the frequency of the category. Fine. Okay, that we have seen in the last lecture, right? Fine.
Yes, ma'am.
Yeah. Then there was a pie chart. Pie chart, what it was representing, it was like circle in which is divided into pieces and which represent proportion of the relative frequencies for particular for given data. And there was some difference also we have noticed in last lecture, that when do we use what was the criteria that if the some frequency table along with its relative frequency it is given, and you have to you are asked to plot a chart, then which chart you will prefer. So do you remember which main difference was there between pie chart and bar chart? There is one difference when to use pie chart and when to use bar chart. Do you remember? We have discussed in last session.
Ma'am, pie chart we can show for share and proportion percentages.
Sorry, can you please repeat?
Pie chart can we show to share proportion and percentages of category.
Yeah, see, whenever relative frequency is there, you can you can have a pie chart. So if you have a proportion, you will use pie chart. But the table is like everything is given, frequency distribution and relative frequency distribution is also given. Then what will you choose? So
Bar
if
chart.
why?
बार चार्ट में मैम उसको वो कर सकते हैं, डिफरेंस निकाल सकते हैं इजिली
And
एक
then
दूसरे से।
what we'll do with the pie chart?
मैम पाई चार्ट में ज्यादा मतलब ज्यादा वो उसको नहीं कर सकते कंपेयर, बार चार्ट में जितने को कर सकते हैं।
See, there is always a difference. Even though you have frequency distribution and relative frequency, it depends on what the question is, what analysis you want. Let's say you want to compare two categories. You want to compare between only two categories. And let's say you have some four categories in your given data set. Fine. Four categories are there or four different values are there. Okay. And you are asked to compare two categories. Between two categories, whenever you want to compare between any of the two categories, or among the categories, when you have to compare between the categories, then you will go for the bar chart. But whenever it is asked, or whenever you have to compare any particular category, compare any category with the whole given observation, whole given data, then you will go for the pie chart, because pie chart will give you kind of percentage, or kind of percentage overview, that how much portion it covers, or how much contribution of that particular category is in the data set. Are
And
you
pie
getting
chart
it?
also show the share of the category.
Let's say if the number of observations are 500, then when you if someone is asking, okay, just give me a minute, I will give you an example. Compare any category with the whole, with the given data set, you can say.
Excuse me, ma'am.
Yeah.
Like we can compare like any like first you have told in bar chart that between two categories we can compare.
Yeah.
In pie chart also I think that we can compare according to the percentage
Yeah,
between
you
two
can have.
categories or more than two categories. Like it because it is clearly shown in the pie chart that this product is this much of the percentage and everything is defined.
Yes.
So I'm just confused a little.
See, it's just a minor difference between both of them. When like it's like someone has asked me a question in initial only. That was also related to, like, that was somewhat similar to it. Let's say there are some four categories, A, B, C, and D, and for A, let me just let's say you have some four categories, A, B, C, and D. Fine, and you have 500 observations, and given that for A the number of observation are, let's say, 250, for B it's 100, and for C it's again 100, and for D it's 50. Then you can have bar chart and also pie chart also, both of them. But when you go for the pie chart, let's say, then it will be like A will cover some 50% of the data. Fine. And some B and C will be kind of same 20%, right?
Yeah. Yes.
See, it's not perfect because it's not showing 20, 20, and 10 distribution. I just assume they are same. Okay. So 20, 20, and 10%. Fine. So when you want to conclude anything in terms of percentage, you can have it as a pie chart, or else when you want to precise with the numbers, then you just go with the bar chart. That will also one of the main difference. See, here in this case, the thing is the numbers are very easy to look, right? It's very easy to calculate percentage and numbers, everything here. But sometimes when it comes to real life data, it will not be like that. So either you need some percentage kind of data, or percentage kind of language, or sometimes you need numerical form. So that's what one of the difference between them, between bar chart and pie chart. We will look some example uh, from which you will be able to distinguish how, like, which chart should be used there. See, in every situation, you can work with both of them, but there are some methods which will be time saving and more effective for particular context, right? So we will learn about that.
Ma'am, when we have several types of variables, then we use bar chart, right?
Yeah, yeah. See,
And
it depends on the context or what kind of analysis you want. Even though with a different kind of variables, you can go with the pie chart also. But it depends on
but
what kind
but
of
we when
analysis you want.
but we when want to show comparison, then also use
And then also,
bar chart. We can use when we show comparison.
actually, your voice is breaking down. So can you repeat again? Or you can put in the chat. That is also fine. I will read. So till now, let's move to the next question regarding that.
Yes.
Yeah. See, the result of the class president election in school is declared, and if Rohan wants to show the number of votes received by each candidate, then for this purpose, which graph will be most appropriate? See, now there will be a context, so you will be like able to relate what I was saying.
Yes, ma'am.
There are some people who have not joined peer deck. Please join the peer deck. No? Like we will have this type of session in every weeks. So once you get familiar with that, that will be fine. So that's why I'm asking you not to reply in the chat. Okay, so what do you think? Which kind of bar or chart, like bar chart or pie chart, we should use?
Pie chart could be a
Ma'am, bar chart.
Bar chart is used.
Bar chart. Yeah.
Bar chart,
Ma'am, there
I
is
Okay.
think.
yeah.
Those who are asking me the questions there, do you get what was the difference there, bar chart, pie graph? Even though we can show the same thing in pie chart also, but we are preferring bar graph here because we want exact number of votes received. Fine.
I
Yeah,
think
the number can be compared.
Yeah.
yeah.
Between the students.
If we use like the pie chart, then it is very like tedious work, or it will be not very because in small number of votes can also be given to a particular student, so it will be tedious. So
Yeah.
representing a bar graph will be sufficient, I think. Yeah. Yes, ma'am.
I
Yes,
got
please.
it.
Okay. See, those who are asking, you have to join with you just open your browser and type there joinpd.com, and it will, once you type that, you just enter it. It will ask you for the password, and password is on the screen on top right corner. Put that password without any space, and then you will be joined there. So yeah, it was clear. It was bar chart only. The similar another one, if Manohar wants to show the percentage of expenditure of his family on different article like food, education, entertainment, and clothing, then which chart he should prefer?
Ma'am, sorry to interrupt.
Yeah.
What was the answer for the last question?
Last one, it was
Yeah.
bar chart.
Okay, got it. Thank you.
Oh. So yeah, for this one, what will you prefer?
Pie chart.
Pie
Pie
chart.
chart. Pie chart.
Pie chart.
Pie chart.
Okay, pie chart.
Rachel.
Pie chart.
Fine.
Ma'am, I have a doubt.
Yeah.
Like in a uh, Pareto chart, is it necessary for the frequencies to be in ascending or descending order?
Yes, yes. That is the only difference between bar chart and Pareto chart. When it comes to Pareto chart, there should be an order, either increasing or decreasing.
Either increasing or decreasing.
Yeah.
In lecture, ma'am showed the Pareto charts in descending order only, and when I Google it, it shows specifically descending order. So I thought the order is
Yeah, general, like
mandatory to be in descending order.
most of the books follow descending format only, but there are some who use ascending also. So that's why we say either ascending or descending. Okay.
So what is the exact answer in
Both are correct. You
IITM?
can go with the ascending also, and you can go with the descending also.
Sometimes it differs. Like we have learned that whole number starts from zero in our schools. But here, in lectures, professors taught us that natural numbers will start from zero. So some very few
Natural number starts
distinct
with
syllabus.
1, no? Okay, fine.
Yeah, but
For this
this
course,
is
it is
for
0.
computers. It differs because
Yeah.
computers won't understand whole
Yeah.
numbers and natural numbers. Just
Yeah.
zeros to.
That's what particular machinery thinks is there, right? Okay.
But in our schools, we have learned
Yeah,
that whole numbers will start from zero and natural numbers starts from one.
Yeah, exactly. So then on safer side, you can go with the descending. But
Descending.
see, this is just not for the degree. I'm just telling you, in future when you will be at some places where this kind of things comes, then just keep in your mind that okay, this ascending or this is particularly saying about the Pareto chart. It may be possible that some are using the increasing kind of things, right? So just take care of that. For particularity, I will say, okay, you just go with the descending. As ma'am also in her lecture, the professor went for the
Yeah, ma'am
descending.
also shown in descending order only.
Yeah. So you just follow her, no problem.
But in the activity question, there was a question that was asking which graph is in Pareto chart,
Okay.
and the answer is both.
Yeah, both ascending and descending both. Because it is also one like that's why we say Pareto chart is either you can have Pareto chart either in ascending order or descending order. It's your choice what you want. So when it comes to multiple selective and both are the option, then both are the correct. Okay?
So it's better to choose both in
Yeah,
exams.
both. Yes. Because both are correct. Even ma'am also have in her lecture, she has told it is ascending or descending. Or even in this presentation also, I in one part there was I said that it is either ascending or descending. Yeah, see here. Pareto chart, it is beans are arranged in either ascending or descending. Fine.
Yeah.
Yeah.
What it is.
Both are correct. No problem. So yeah, better to clear if you have doubt. No problem. Okay. Should we move to next question?
Yes, ma'am.
Okay.
Yes, ma'am.
So yeah, here there is one pie chart is there. The cells per day of different colors of 80 pens in shop is given by the following pie chart. How many blue pens are sold in the shop?
Reduce the time.
See, once I receive all the responses, I will close it, like, and timing will be closed. So keep patience if you have done it faster.
Hey, ma'am,
Yeah.
I'm sorry I joined a little late. Can I have a link to the place that I can reply with answers?
Yeah, you just go to joinpd.com on your browser,
Join
and there
PD.
joinpd.com.
Okay.
Yeah, and put this password. Password is on the top right corner.
All right. Thank you.
Yeah.
Ma'am,
Yeah.
can't we round off relative frequencies to
Like
find the answer?
sometimes, like for this kind of question,
Not
when
here,
yeah,
practice
I'm
assignment.
just saying, like sometimes it will be easy to round off it, but whenever, like, we avoid it if possible, or if it is becoming very difficult to manage that number, we will round off it. But while rounding off, just take care that it's summing up to 1 only.
Yeah, that is okay.
Yeah.
Uh, for the second question, I have put 0.7. It's showing incorrect. They want 0.701 or 0.702.
Okay, for that, they might have cleared there that you have to put your answer till 3
No,
decimal
ma'am,
point or so.
I have read the question two times. It's not mentioned
Oh,
like you have to enter the question, so answer in this much
okay,
decimal
okay.
places. In few questions, it's mentioned.
Yeah, okay. But yeah, we generally avoid it, but sometimes it's unavoidable, so we round off it. Okay, how many blue pens are sold in the shop? So you have total number of pens there, and you also know the number of blue pens is 12.5% of the 80. So you have to just calculate what is the 12.5 percentage of 80, right? That is one thing.
Yes, madam.
And another one, you can go with the formula. That's what? Frequency formula, no? Yeah, this, if percentage is given, if the quantity
Okay.
is given in percentage
Yes.
format, you
Yes.
can have relative frequency, right? What will be the relative frequency here if the percentage for particular category is 12.5, then what will be its relative frequency?
0.125.
0.125. This is your relative frequency. Fine. And you know the total value of total number of observation also. So you just have to calculate frequency. So just put in the formula and you will have frequency. So yeah, what number it was?
10.
10.
Okay.
And
So yeah, just calculation only. Yeah, 10.
Please.
Okay. Any doubt in this particular question?
No.
Oh, fine.
No, ma'am.
No, ma'am.
Okay. Then cumulative frequency. Uh, Someone has asked a similar question in the starting only, right? Cumulative frequency of observations means addition of each frequency of the given observation. So sometimes they will ask cumulative frequency of particular category only. Let's say there are some n number of categories, let's say x1, x2, xn, and their frequencies are like f1, f2, fn. And then if they ask the cumulative frequency of three categories, let's say x1, x2, and x3 only, then it will be nothing but the sum of the frequency of these particular categories. Fine. And the word in that particular question someone has asked, it was aggregate, right? So both are the same things. Okay. So let's see the question based on it. Calculate the cumulative frequency of red pens and black pens sold in the shop. Okay. Is it done or you need more time?
Done.
Okay. Yeah.
Yes, ma'am, done.
Okay. Fine. See here again the same thing is there. Just a calculation part is there. For red pen you have 25%. You have to calculate 25% of the 80, and for black pen you have to calculate 37.5% of the 80 pens and just add it. That's it. So what number did you get?
50.
50, ma'am.
50.
Okay,
Ma'am, it will be 50.
great. The same. Okay. So yeah, there we had one more concept, mode.
Do we have to put them in order?
What?
Do we have to put them in order to find the cumulative frequency? Because if the order changes, the cumulative frequency will change for few values.
How? Like, see, cumulative frequency is just sum, right? So, and summation is associative. So you can add Like it doesn't matter when are you adding it, isn't it? You just add 20 plus 30, it will give you 50. Even though you add 30 plus 20, also again 50. So as it doesn't matter.
Ma'am,
Yeah.
I also have the same question. Like for here only there are they
Ma'am,
are
can you go
asking
to the
for,
chart?
like
Yeah.
they are asking for the cumulative frequency of only two pens, two color of pens. Then we are concluding that the answer is 50. But if the number of pens increases, like if you want to find the whole for this whole pie chart, the different type of color of pens, if you want to find the cumulative frequency of those, then I think order is also important, ma'am.
No, you can calculate randomly also. See, can you just tell me if you calculate the sum of all, what will be your sum?
Like some of
Sum of all the pens.
all the pens, it will be 80, ma'am.
80,
only.
right?
Yeah.
Now if I ask you to just add first, let's say for blue pen, we have some calculated what it was, some 10 number of pens were right there.
Yeah, 10. For blue, 10,
For
green,
blue, it was 10. For red and green, it's 20, 20. And rest
20,
of
yeah.
black are rest of them, right?
Black is
Some,
30.
yeah, some 30. So you just add 10, 20, 20, 30 or 30, 10, 20, 20. Doesn't matter,
Ma'am,
right?
so for every axis, here axis is black, green, red, and blue. So for
Axis,
every
okay, portion
like
you
for
can say.
every ma'am, every pen, every color of pen,
Yeah.
we conclude a communicative frequency while by adding all the number of pens only.
Yeah. Yes.
Okay.
By just add the number of pens for the black, then for blue, and green, and red. So it
For
doesn't
each
matter
pen, we
what.
cannot like
Yes.
ma'am, for each particular pen, color of pen, we cannot say the cumulative frequency. We cannot conclude that.
See, cumulative frequency, whenever cumulative word is there, with any kind of a parameter it is, whenever it is there, it's for more than one quantity.
Okay.
See, if you are calculating the, you are saying, okay, what will be the cumulative frequency for the black pens only? Then I will say there is nothing, nothing like that cumulative for a single category. Whatever you calculate for the black pen number, it will be a number of black pens, right? It's nothing but the frequency only.
Yeah. Yes, ma'am.
Yeah.
Okay.
Okay.
Understood.
In any sense, whenever the cumulative word comes, it is the sum of more than one categories.
Okay.
Okay.
Thank you.
Okay. Yeah, someone else also was asking some question.
Ma'am, for the total frequency, it's okay. No, I understand that the order doesn't matter, but if in case if we want to find the cumulative frequency of any distinct value, like for example, for the blue, if we take in a row in a column from the green, blue, black, and red, in that case, um, we'll
Like
get
this,
something,
green,
green.
blue, like this, right? Or in row you want to?
No, in a column,
Okay.
like in a column,
Okay.
top to bottom.
Okay, fine. Green, blue.
25% means 25 by 102.
Okay, green, blue, black, and red. Then what?
18, 1 by 4, 20. Yeah, and then if we find the frequencies, we get for green it is 20.
Yeah, 20. For blue, it
For
was
blue
10.
it is 10.
30 and
For
20. Yeah.
30, okay. Now if we find the cumulative frequency for blue,
Yeah.
we'll get 20 plus 10, 30.
Okay.
And if
That's
the
somewhat
order,
different thing.
if this order will differ, we'll get something else for the cumulative
I
frequency of
got your
blue.
point. That is some different criteria. That is some different concept that we have not covered yet. Okay, that comes into picture when the data is grouping kind of data is there, and there is some order in your category also. Here, with your category, that means category means green, blue, black, red, right? Is this understood? This color of the pens, right? See, there is no ordering between this green, blue, black, and red. It doesn't matter. You can say someone tabulate it as a red, black, blue, or green, right? It doesn't matter. Order doesn't matter here. So, for this kind of things, cumulative frequency will be just adding, there will be no sequence. But when your categories will have some orderings, like let's say, once we have seen one question in this lecture, that was some marks interval of the student, right? In particular exam. There you will always find that data will be collected in this pattern. Like let's say first row will denote the number of student scored 50 to 55, then 55 to 60, right? It will not be random 60 to 65. It will not be random that in the first row you will find 60 to 65, then in next row you will find 50 to 55. Are you getting my point? Like this is what called a grouping of data, and also some order is there with the category itself or
Yeah, it's
the
a
distinct
good.
value. At that time, what you are saying, that is valid, but that is we have not covered yet. It will be in next session, next lectures also. Okay, but for here, when it comes to just adding, like to find the cumulative frequency of this kind of data, there is no such things are there.
But this is not a grouped data. So
Yeah, that's why here
what
even
about the
the,
cumulative frequency for this one?
for this here order doesn't matter, as the data itself do not have any order, and grouping is also not there. So you just say that here order doesn't matter. Okay.
Okay.
So yeah, mode. What was mode? We have discussed this, right, in last lecture. So whenever there is a categorical variable or numerical, we can always find the mode of the of any kind of data. So it is nothing but the category with the highest frequency. Mode is defined for both ordinal and nominal scale of measurement. If two or more categories tie for the highest frequency, the data are said to be bimodal or multimodal. Let's say if some categories have same number of counts or same number of occurrence in particular data set, then that kind of data will be a bimodal. But yeah, that category, that number should be the highest one among the data set. We have seen the examples, right? Like let's say there are some categories A, B, C, and D. Even the last question also, where green, red colors were there, pens were there. Let's say A, B, and C has 20 number. This is frequency, okay? If this is frequency table, then I will ask what is mode and is this the bimodal data? What will you say? Is this a bimodal data?
No.
No. Why? Just a minute. Who said yes? You should reply like why it is a bimodal data. Okay, fine. Anyone? Is this a bimodal data?
There is only one
No.
category with highest frequency,
Yeah,
and that is the
that's why
30.
this is not a bimodal. Here, the only one category is with the highest frequency, that means D. But if I change the data slightly like this, then what will you say? Is this a bimodal?
Bimodal.
Yes.
Then yes.
Bimodal data.
So repetition of a count doesn't matter, but if any category with the highest frequency and there are more than one category like that, then it is a bimodal. Fine. Okay.
Ma'am, I have a question. Like when we are dealing with relative frequency tables, is it possible for us to represent the same relative frequency in the bar chart and Pareto chart also? Or are we always using the frequency plots there.
Mm, yeah, like it is also proportion there. You can use it, but you will not find any meaningful thing, right, from there.
Yeah.
So that's what we have one concept called pie chart. Because with relative frequency also you can plot a bar chart and a Pareto chart, but it will not give very precise information regarding whatever your data set is. Better to have the same. See, let's say you have like created a bar chart using the relative frequency and you are presenting it somewhere, then people will be confused like whether it's a particular value or you are showing them a proportion of the things, right? Because when
Got it.
when the same thing you will present the same thing in pie chart, they will understood that this is not a particular value. He is presenting some proportion of the category, right?
Yes, ma'am.
Okay. Median. So median is defined as the middle value in the order data, either ascending or descending. Those who have attended last lecture, we had some question at at the ending of the session, right? When median was, we were calculating median. We have to arrange all the data in ascending or descending order. And if the number of observations are odd number of observation, then the middle one is your median for that data set. So how to find the middle one? So it's nothing but the n plus 1 by 2, right? And what if the data, the number of data is even number, if like if there is even number of observation, then your median will be either the average of n by 2 and n by 2 plus 1, or it might be n by 2 or n by 2 plus 1. Okay. Or sometimes both also. Median is not defined for the categorical variable with nominal scale of measurement. This kind of example also we had there, right? If there is only nominal scale of measurement, you can't have median. Why? Because there is no order, right? Did you get the last point? Why we can't have the median for the nominal scale of measurement? A categorical variable who has the nominal scale of measurement, there we can't find the what is the median. Because you will not be able
Because
to.
in median, we have the ordered data.
Yeah.
We must have the other data.
Yeah.
Like in the nominal scale, the order is arbitrary. We
Yeah.
cannot define a particular order.
Yeah. There is no order, so no median is there. Like you can't find. Okay. So yeah, the responses given by Suman on several tosses of a coin is given below, where T stands for tail and H for the head. Identify the mode of the response is tail, head, or bimodal. Okay.
Hello, Dharti ma'am. Hello.
Hello.
Yes, ma'am. Your voice is very faintly audible.
Oh, sorry. Like from when it is?
From the starting, it was okay, but after that, sometime it became faintly audible.
Okay, okay, okay. Just let me know if there is any such kind of thing. Is it fine now?
Yes,
I
ma'am.
think you are clearly audible.
Okay.
Yes, ma'am.
Okay. Okay.
Ma'am,
Yeah.
for nominal categories, if we define frequencies for each category, and we'll order them based on the frequencies, in that case, they will be ordered. So, can we find the median in that case?
Uh, I will just let's say for this particular example, here it is nominal, right?
Yeah,
Now
it's nominal.
you may have got the number of heads and number of tail here, right?
Yeah,
Now, what will be
heads are
median
8
there?
and tails are 7.
Then if I ask you what will be the median, then like what will you say? It's you can't arrange in short, you can't arrange according to the frequency and find its median. It's not that. It's not like that. Your like cases or category variable, it should have ordinal scale of measurement, because frequency is a number, right? Frequency or count or occurrence. This is what you will always have numbering there, right? So at any point of time, you can arrange them in a ascending order and you will say, okay, this will be, this corresponding value should be a median. It's not like that. Your category variable for which you are finding the things, that should have ordinal scale of measurement for it. Okay. So did you get
Okay,
my
but
point?
yeah, in group data, we can use frequencies, right, to find the median.
Yeah, there is something different. Like there is
Okay.
some different scenarios there. We will, I like,
Yeah.
I think
I
in week
remember
3
in
it will be there.
yeah, in my 10th standard, I was
Yeah,
finding median using frequencies only. That's why little confused.
yeah, it is there.
Ma'am, hello.
Okay, hello, yeah.
Ma'am, can we discuss here practice assignment 2.2?
Let's say if time permits, then we can.
Okay, ma'am, there is down.
Yeah. So yeah, for this one, what is the mode? Did you find
Head,
what are
ma'am.
the head
Head.
or tail?
Head.
Head. Head.
You just have to count the numbers of heads and tails, right? So 7 tails and 8 heads. So highest frequency is with 8. So you have mode as head. Okay. What can be said about the median of the responses for the same question? The median of the
Not
responses to
defined.
you. Yes?
Not defined for the given year.
Because it is
Okay.
categorical data.
Yeah. Just put this answer here.
Ma'am, you are not audible.
Hello. Yes, I was in mute. Hello. Yes. So what were you saying? Hello. So yeah, what can be said about the median of the response? The median of the response is tail or head or what?
Not
So
defined.
Not
Not
defined.
defined.
it's not defined, right? Because the data
Yes.
set is a nominal. Data set have nominal scale of measurement. Fine. So this
Okay.
were all about the questions, yeah?
Ma'am, but here comes a doubt, like for a particular arrangement, whether we took head first or tail first. In both this ordered arrangement, we will still have a head at the median because number of head is more than number of tails. But because it's not ordered data, we are not linking
Yeah.
itself with this median thing. So
Yeah.
it's a bit.
Like you can see it like that also, that when we calculate median, we arrange are these data. in ascending order. So we can't have like any order between head and tail, right? That head is greater than tail or tail is greater than head. There is nothing like that.
Yeah.
So you can't arrange your data in either ascending or descending. Hence, it's not possible to define the median here.
Yes, sir.
Yeah. So yeah, this was all about the questions for today. So there is some concepts there like tips to solve the questions, like what is area principle? These things we have also discussed in last session also. Area principle, that means display of data must follow a fundamental rule called area principle. Area principle says that area occupied by a part of graph should correspond to the amount of data it represents. The same thing we had in last lecture also, like if you are having a pie chart where some quantity A, category A is some 75%, but you are representing A as like this, then it is not a correct way of representation, right? If you are saying, okay, this is 12%, this is 12%, and this is, let's say, 76%, then this is not a correct observation, right? So
Right.
your area should be, area should also represent some amount at least, not precise. If not precise, then at least uh, somewhat like by amount, it should be like that. Then misleading graphs, you may have seen what are the misleading graphs. So graphs that do not follow area principle are misleading graphs. I just shown you in the pie chart. The similar thing can happen in the bar chart, that some particular category have more frequency, but its bar height is less than the other things. Or maybe sometimes they start the baseline with not zero. Yeah. Yes. Yes. What you were saying? Okay, and round off errors. So when table entries are in percentage or proportion, the total may sum to a value slightly different from 100% or 1. That is what round-off error is. Percentage do not sum up to 100, then pie chart is said to have a round-off error and thereby does not follow the area principle. So these were some rules or principles regarding the representation of data, and that's all about our session today. So thank you. So if you have any question, then please carry on because we still have half an hour.
Ma'am, I have a doubt regarding median.
Regarding median, yeah.
Like
No.
if we have total 5 frequency, let's take the example of head and tail. If we have 2 head or 3 tail, so if kind of we try to find the median, then tail will be the median. So is it correct way, or the median is not defined?
No, no,
Like
no.
we cannot order the frequencies of
We
the
can't.
data.
We do not have
can't,
to order the frequency of the data. We have to order the data.
Yeah.
Median is C. What definition says? It is defined as the middle value in the ordered data. Ordered data means your data in this particular example, when you are saying about the coin, your data is about head and tail, right? It's taking these two categories as a
Yeah.
value. So for these two categories, you do not have any order. So that's why this is not a order and you can't define median here.
Okay. So we can
Similarly, if I
define
give
median
you the
in
number
only
between
ordinal data.
yeah.
Okay.
Similarly, if I ask you the median from 1 to 5, or let's say this numbers, then you can have something, you can say something about median in this case. So yeah, what will be your median? In this particular case, what will be the median? This boxed part is your data set.
Oh, 4 will be the median.
Yeah. Why you were able to find the median as a 4?
Because the data is ordinal. We can order the data from.
Yeah, you haven't
Because
calculated
above
the
4 there
frequency.
is 2 and below 4 there is 2.
Yeah. If I add one more thing here, let's say again one more 4, then what will be your median? Will it change or will be same?
No, it will only 4. Yeah.
4. Now, what will be the reason for having median 4 again?
Because both it can be 2 median, but both the numbers are same, so it is 4.
Yeah.
Like
2, 3,
if the
4,
number was
4.
something different, so it won't be 4,
Yeah.
or the
So
median will
these
be
two, yeah. So that's why your median is 4. Okay.
Yeah,
So
ma'am. Thank
your
you.
data, in the second example, your data were numbers and they can be arranged in ascending and descending. That's why you were able to find the median. But in the first example, head and tail, you can't arrange them because they have nominal scale of measurement.
Yeah.
Okay. If there is any question, then please go ahead or we can stop here.
Ma'am, if the data is height or weight, then median will be defined.
Yes. With height or weight, you have ascending and descending order, then we can have median.
Okay, ma'am.
Yeah.
Okay, ma'am. Thank you.
Okay, thank you. So you can leave now. If you do not have any questions, you can leave now.
Thank you.
Okay, yeah, thank you.
Okay, thank you, ma'am.
Yeah, thank you.
Ma'am, is this lecture recorded?
Yes,
We can watch on YouTube.
yes.
Thank you.
Okay.
Ma'am,
Yes.
ma'am, can you explain for area principle for pie chart?
Yeah.
Excuse me, a small question. We cannot have 2 medians, no? We can only have 1, right?
Sorry, we cannot have
2 median, like we have the thing for bimodal, so we don't have anything for median like bimedian or something.
Yeah, generally median we give as a single valued answer.
Yeah, we cannot have it 2 like bimedian. We cannot
Yeah.
have a 2 median for a single data.
Yeah, yeah.
It can only be 1.
Yeah.
Yeah, thank you.
Yeah, so area principle someone was telling, right? For pie chart. Let's say you have some data set and you have their relative frequency also. Let's say for A, these are your categories A, B, C, and D. Let's say for A, the relative frequency was 0.5. For B, it was 0.1. For C and D, it was 0.2 and 0.2. Fine. Then, if you go for the pie chart, how will it look like? For A, the pie chart should cover 50%, right? So the
Yes, ma'am.
ideal pie chart should be, this is just a minute. Ideal pie chart should look like this. Let's say A is here. This is B. This is C and D. Okay, this is, let's say, one chart one person has created or give it 4. The another person has drawn like this. Okay, this someone has drawn this like this, and some person has drawn the same pie chart, the same data like this. Let's give number to them. 1, 2, and this is 3. Then what area principle says, it says the amount of proportion should be visible by graph. Fine. So for this particular, let's say, if I draw by hands, then the graph may look like this. Then which is showing the best according among these three? Which is the best pie chart? You can say, okay, this one is following some area kind of things. Okay, 50%. For A, the area should be 50%, right? For B, area should be 10%. For C, it should be 20%, and for D, it's again 20%. Then if you have to choose among these three options, that for this data, which of the following is the, let's say, correct graph, correct pie chart, then what will you say? 1, 2, or 3? Hello?
Ma'am, I think all are correct.
All are correct. Okay, then let me just explain. 3.
3 was correct.
Yeah, 3 was. Why 3?
3.
Okay.
Okay,
Okay, 3. Then why?
A contain 50%
Okay.
and B contain 10% and D and C contain 20%, and here we follow all the rules.
Okay, leave
Explain the
second.
correct proportion.
Can you give me the first one? Can you give me why not first and you chose third one? Because both first and
Ma'am,
third have.
B, C, and D have same proportion in the
same
first
Yeah,
one.
That's
yeah.
why.
In first one, B, C, and D all have same proportion. But
Yeah, ma'am.
here, some visible things are there. Okay, C and D almost same, but B is somewhat less. Even I should also make it more precise. But yeah, but let it be. If it should be like something like B should be somewhat smaller, and C and D, even though it's not it's not created with perfect measurement, but some area by area we can visualize. Okay, 10% should be less than 20%, right?
D and C.
And C and D should look like almost similar, and A should cover almost to 50%. So now let the girl who was saying all three are correct. So I am explaining to you, okay? See, A is covering 50%. That means whatever the pie chart or whatever your presentation is, there your A portion should cover 50% of the area, right? See, this is the whole area. When you consider, this is considered as 100%, this inside, right? So now you have to cover it with A, B, C, and D. How will you go with it? So just have 50% partition. Then it should be a 50% visibly covered by A. But in second option, can you see, is it a 50% or more than that?
Ma'am, more than that.
It's almost looking like a 75%, right? That's why this option is incorrect. But then you will say, okay, in first and third option, A is covering almost 50%. Then why only 3? Then let's move to the next one. That is come to B. B, C, and D. So B is covering some 10% and C is covering some 20%. But percent of what? Then I said, okay, of total area. Let's say 10% of total area is covered with the B and rest of the 20% by C and D. So in this particular case, you have to see whether your A portion is having some 50% area. The area of B and C should show some difference. That means area of B should be less than area of C, and area of C and D should be equal, right? Because both of them are 20-20. Are you getting my point?
Yes, ma'am.
Yeah. That's why option 1 was not correct, because it was showing B, C, and D as contributing the same area. So that's why this is also not following area principle, but this one is following area principle. That's why we went for the option number 3. Okay?
Yes, ma'am.
Okay, fine.
Hello, ma'am.
Yes.
How to find the relative frequency of some group of categories?
That is actually not yet covered. So we should discuss
But
in next lectures, right?
there are few questions like this in practice assignment
Okay.
and
Fine.
activity.
Okay. What do you want actually?
Um,
Relative frequency, right?
yeah,
So did you try the way we are using for the normal data?
yeah. I thought relative frequency of some group of categories means the summing their frequencies and finding the total frequency. Uh, Based
Okay.
on that, we have to find. But in here in the solution, they have added respective relative frequencies. So there was a question I have dealt previously wherein the correct answer is based on the method I have done, but here
Okay.
it's not working.
Here,
So
till now, if you are talking about the assignment till week 2, then I will say, even though it looks like a group data, but it's not. Like this one that we today shown in our session. Just a minute. This first question, it seems, are you able to, is it visible like screen?
Yes, ma'am.
Okay. Just have this question, even though it looks like it is in group data, but it's not. You can have them as a B, C, D kind of things. This marks interval it was. Yeah, this one. See, will you say this is a group data?
yeah,
But actually yes, but directly the table is given and you directly have the counts here, right? So
yeah.
here, when you calculate relative frequency for particular this thing, then you have to count the frequency, right? You have to find the frequency or
Actually,
count of the numbers of people having the marks between 50 and 55. Once you have this frequency, then for relative frequency, you have to go like that only, like frequency divided by total. That's all.
yeah, that is okay, but I mean not this group data. Um, like in a question, it was asked to find the relative frequency of some group of few categories selected from them based on some common property.
Okay.
Like there is a
And
question.
there you for that particular question, you have to create a table in which they have defined a category, right? For that categories, you have to calculate the frequency or number of observation that falls into that particular category, right? Once you are come up with that number or with that frequency along with one category, then to calculate relative frequency, again you will use the same formula, not the different one. Did you understand? Or
Frequencies of each categories are already given.
frequency of
Frequencies are already given for each category.
it is given for already each category. Then why then what's the problem with the relative frequency? Do you know the question number?
Yeah. Can I share my screen?
No, I will share the screen.
Okay.
Just tell me where it
So
is.
practice assignment 2.2.
Just a minute.
Question number 8.
Practice assignment 2 point.
2 and question number 8.
Okay, okay. This one, right? Question number 8.
Yeah,
Okay.
yeah, that one.
What is the relative frequency of first language speakers for Dravidian language in India? Dravidian, okay, fine. So for that, you have to, yeah, what did you do? You just first
I
sum.
have just summed these frequencies of each language: Kannada, Malayalam, Tamil, and Telugu,
Telugu. Okay.
and then I have divided it from the total of the
But why?
languages.
It is just a sum, na? It's a percentage of total population in India,
Yeah.
right? So isn't it just a sum?
No, it's a relative frequency that I'm finding.
Okay, this is percentage of total population, right? I
Yeah.
just told in the lecture that if you have percentage of any data, you can come with the relative frequency from the percentage of population. Were you there at that time? So if
No,
let's
no.
say for Bengali, the percentage of total population is 8.03, then if I ask what is the relative frequency for peoples who speak the first language as a Bengali, then what is your relative frequency?
8.03.
No, I am asking you relative frequency. How relative frequency can be 8.03?
Oh,
Because the
okay,
sum
okay,
of the relative frequency can be at max 1,
okay.
right? Is always 1.
0.0803.
0.08003, right?
Yeah.
So the same thing. You already have relative frequencies of the whole data, and they are asking about what? Some Dravidian people, so you just have to add them. That's it.
And the percentages. Oh, okay. And the
Yeah, just
relative
add the
frequency.
percentage and convert it to relative frequency.
Sorry for the
Okay.
interruption, ma'am.
Yeah.
Excuse me.
Yes.
Ma'am, for some reason I didn't attend this session. So can I get any PDF or is this session is recorded?
This session is recorded, and if you guys want that PDF, then I will share that PDF. Yeah, that will also be shared with you. This presentation slides.
Okay, ma'am. Thank you.
Yeah. And you will have the lecture on YouTube also. Okay, for whom, for the person who has asked this question, is it clear? Hello?
Yeah, yes, ma'am.
Okay,
Thanks.
okay, fine.
Ma'am, I'm having a doubt in practice assignment of week 1, 1.2.
Week 1.
Just a short doubt. Yeah.
Okay, 1.2.
1.2 practice assignment.
1.2. Yes,
Third question, ma'am, please. Third and fourth.
this one.
Yeah.
Yeah, here, what
Uh,
kind of
uh,
variable?
I am having a bit conflict. Like rating, one thing is certain that it is ordered data. Means it's either categorical or discrete numerical variable. But these ratings are arbitrary. Like some user is rating an app, so it's more of like categorical. So why are we? It's just label, even if we are naming it as 1, 2, 3, 4, 5.
Okay, okay. Just a minute, okay. This is rating given by user, and this is rating given by apps. Okay. So yeah, what kind of variable is? See, rating you might have seen in the 1, 2, 3 format only, like this user. Then it is just a discrete numerical. But when it is like given by app, So they sometimes average it, or by whatever the reviews they got, they average it. At that time, it takes some continuous numerical kind of variable, like numerical continuous format also. So
Ma'am,
yeah,
but it's equivalent to saying that I rate an application 1 star, 2 star, 3 star. So that's definitely it's just a way of representing that it's means it's something like this.
hmm.
But it's not exactly a numerical thing. So why are we considering it as in the numerical sense? Means with the what thought or something.
Hmm. You might have observed in various sites like Amazon or Flipkart, there are some items where you will find that some stars are fully yellow colored and some are half yellow
Yes,
colored.
ma'am.
Yeah.
Yeah.
Huh. Why they are like that? Why they will mark like that? From where that coloring? How they are doing choosing that coloring? Do you have any idea?
Yeah, that's the average rating, some sort of average rating or something.
Yeah. So the primary thing to cover that stars, you have behind the scene there are numbers, right?
Yeah.
And that numbers are in uh, when there are half or more than half, less than half, this kind of things are there. The numbers are like that, right?
Yeah,
Continuous.
ma'am.
That's what the continuous things comes into picture.
Hmm.
Yeah, therefore it is continuous here, here in this particular case.
Hello,
But
ma'am.
representation comes later. First, it came with the numbers. So when you are at the stage of you are the person who is seeing the numbers, then for you who is dealing with that numbers, for you the data is continuous numerical. But at the same time, when I am visiting the site, you are the backend worker, so you have exact things, right? But I am seeing on the site. At that time, for me, it is discrete, isn't it?
Yes, ma'am. It's discrete, but is not that much of a context dependent? Like if you just show someone that I'm labeling that 1 star, 2 star, 3 star, 1, 2, 3, 4, 5, then he might consider it as categorical or some discrete numerical label, but that's just dependent upon the context in which we are using it.
Yeah.
Okay. But one more thing, like having what is the difference between rating 1 star, 1 and 2 is not same as what is given difference between the rating 4 and 5.
Yeah.
So in the fourth question like this, interval scale is not fixed. It's order, I agree, but how means this difference numerically it's same, but numerically it's just a representation. That is not an exact thing. So why it's interval?
Why it's interval?
Yeah.
See, they are asking for the rating given by users.
Yes.
So at that time, I will say it's a data specific question. So they are saying a rating given by users. So you just look at this data. This data is 43254. Okay. There is some like there is nothing like they are jumping out of the range. They are having particular interval 2 to 3, 3 to 4. The interval means difference between the
No,
subtraction. It's a
yeah.
subtraction only. It's not a doubling or tripling the things. Like that's what you said. Difference between 1 to 2. Like someone has got the rating 2 and someone has got rating 4. That is not the same distance they are traveling for getting that rating, right?
Yes, ma'am.
Yeah. Logically, it's not like that. But when the person is giving the rate, uh, for numerical sense or for this particular data set, there is one particular difference, one fixed difference between each and every value. Whatever the values it is taking, let's say 2, 3, 4, and 5. These four values are only being taken by them. And they all have the fixed difference between each other. That's why it's an interval.
Ma'am, is there any else context in which we treat this categorical data as numerical and interval scale, this ordered data as interval scale beside this rating system?
Uh, like you have to see the data only. That's the only way.
Okay, yeah.
Yeah.
It's dependent on how we are going to
Yeah.
interpret it. Okay.
Excuse me, ma'am.
Yes.
So the same question. Does it mean that when they ask such a question, and so the question says, what kind of a variable is the rating given by each user to an app? So it's like they're asking
Just a
on the
minute, just a
behalf.
minute.
Yes, ma'am.
Your voice is not clear to me.
Am I audible right now?
Yeah.
Yeah, okay. So in this, the question is, what kind of a variable is the rating given by each user to an app? So from my end, I will only be giving integers, right? Like either 1, 2,
You
3,
are
or
only
4.
given.
I'll only be seeing numbers which are like 1, 2, 3, 4, or 5,
Yeah, this
and
one.
not decimals.
Yeah.
So wouldn't it be valid that it will like when I answer the question, am I supposed to then think that it will be at the end of the day used for an average? So hence it is a continuous numerical variable.
Hence, sorry, the last statement I didn't.
Yeah. So matlab, it's like if I'm just seeing
The
like
user data only.
yeah, I'm just seeing numbers like straight
Yeah.
4, 3, 2, 1, and 5.
At that
But
time, your whole context, or let's say the whole observation, will be this data only.
right,
For you, doesn't matter what kind of rating is given by apps. So you
right,
have this as a data, and now you
correct.
have to analyze about this data only. At that
Okay.
time, what will you conclude? That's your conclusion for this
Yes.
particular data set. Yeah.
Huh.
That is what descriptive analysis is.
Okay. No. So I'm just saying, like, why the same question that he had, like, why wouldn't I think about it as like discrete numbers instead of continuous numbers? When I'm the one who's giving just one number or like.
Yeah, it is discrete.
Okay, so it is. Wait, can you just like pull it down so I can see the options again?
Yeah, it is discrete. Yeah.
Okay, so it is a discrete numerical variable,
Yeah.
right?
For user. Rating
for the
given by
user.
rating given by user and rating given by app. This is two tables, right?
Huh.
For table ratings given by user, it
Huh.
is a categorical data, which
Okay.
is ordinal, and which also has scale of measurement as interval.
Okay,
And
so
when
sorry,
you
just
say me numerical, in terms of numerical, it's a discrete numerical data.
okay, it is discrete. So the first answer is discrete numerical, right?
No. First question is about about an app. Like the table is different. What kind of variable is the rating given by each user to an app?
Okay, to an app. Okay,
Hmm.
okay, got it.
At that
Okay.
time, you have to
Right.
look out to this table. At that
Got it.
time,
In context to an app.
yes,
So
yeah.
the word the phrase to an app is more important, right? Like that's
Yeah.
what I have to think. Okay,
That's
got
why
it.
it's for table number 2, it's a continuous numerical variable.
Yeah. Okay, it makes sense. Makes sense. Okay.
Yeah.
Thank you, man.
Okay, thank you. Okay then. We are closing here. We'll meet you soon. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you. Bye.
Thank you, ma'am. Thank you for the session, ma'am.